So everyone, welcome back from the lunch. And we are getting ready to the next session. We have so far heard quite a lot about the research conducted at the different research infrastructures, collecting data on that. And now we are looking at the impact of the research to the societal challenges and relevance. We heard this morning from the opening speak that all the research has to have a societal benefit and societal relevance. And in this session, we are talking about that. And we will have, like in all the previous sessions, we also have opening talks, and then we will have a panel discussion. And our first speaker in this session is Søren Rysgaard, who comes from the Aarhus University. He's a director of the Arctic Research Center and PI of the Greenland Integrated Observing System. In parallel to his scientific studies, he has been instrumental in building up a strong research consortium, Arctic Science Partnership, and led several large international research projects and built up sophisticated research infrastructure in Greenland, Denmark, and Canada. Søren, thank you.
Thank you very much. I will talk a little bit about two things that we have started. One was started last year. It's called the Greenland Integrated Observing System. And the other one is called Isaaffik, which is Greenlandic and means the open gate or the portal. The Greenland Integrated Observing System was created because we knew in Denmark, Greenland and Faroe Island, there was a lot of different institutions working on all kinds of things, but we had no real idea of exactly what was the overview here, who was doing what, where, and when, and how could we increase our knowledge so it could be used also for the public good. And so we got the task and the money to build a research infrastructure. It's built on existing infrastructure, and it will be built up over the next 6 years. And then the partner institution will carry it on long term. And it is a lot of, if you have noticed the previous talks, there are a lot of the different institutions and research infrastructure that is also part of the GEARS, or actually composed of the GEARS. And the idea was to get an overview, and I am happy to see that also in the previous presentations that some of the information from Isaaffik was pulled out also on a more global context. But it requires a lot of work on the national level and an institutional level to keep the data streaming in. So we also got money to upgrade the infrastructure. So we pull everything that was there. You can go on the homepage and have a look on all the updates that we will do, but I can just mention a few of them. One was we will boost many measurements from atmosphere, land, ice, ocean, and so forth. And one of the things, as an example, was the Watson River and the bridge that was crashed in 2012 due to a flood from Greenland ice sheet. It will be reinstalled, and there will also be other parameters included there. When the Promise weather stations was established all around Greenland, nobody was thinking of rain collectors. So all the meteorological instrumentation is designed about capturing snow. But now it starts to rain even high latitudes in the Greenland ice sheet. So this year, all the weather stations was upgraded with rain collectors as well. A third thing we have started is to make mobile observatories. I'll come a little bit back with a few pictures of what that is. But the idea is that you have a small central power station that you can run by solar and wind, a ton of batteries and some server, and then you can collect data from the environment and transmit real time. And if this is going to work, which we hope, they can start to talk to each other and also transmit data to each other. One other thing of the GEARS platform and the collaboration was that we will try to make it green. So actually already this year, Sakkenberg Station has been upgraded with solar panels. The Billum station they were a little ahead of us, so they already did it. Next year, the Greenland ice sheet dome will be covered by a solar panel and run carbon fossil-free, except from getting people up there. But when they're there, it'll be run solar. Much of the instrumentation, like the one in the center, is run also by solar. And up in the corner, we are pushing the limits to see how much power can we generate even on the in the dark period. And of course, the further north you get, the more dependent you get also on other things at solar. But it seems to go right. It's not straightforward, but we have been successful the last 2 years in the tests. Here's an example of one of the mobile observatories where it's sitting. So basically, you can sling it in by helicopter, you can sail it, or you can get it to land. They can be distributed to different places in the landscape. They can collect wireless data from the atmosphere, from instrumentation from the Greenland ice sheet and down the valleys, and then also into the fjords by magnetic induction. Right now, this is only a coastal settings, and they are because we can only go if we have to power it renewable. We can power it to a few kilometers offshore. The good thing with Greenland, though, is that it is kind of steep, and if you place them in the right places, you can get the measurements in from the different water masses anyway. So the data is fair, and I learned now that there's another place. So what we've done is that we are always reporting our data directly into the repository that the different scientists are doing. But we have also made an overview of, or we are still working on that. We have started with an overview of all the metadata and where it is from this Greenland Integrated Observing System. We put it into this internet portal Isaaffik, where we also host a lot of other things. And before going into that, I will just also show some of the recent development that we have done in the Nordic countries. So we have had meetings actually last month, I think it was, with colleagues from institutes in the Nordic countries, try to bridge the Fram Strait. So we have the GEAS, which is the Greenland Integrated Observing System. Svalbard has the SIOS, Svalbard Integrated Observing System, and we have used these observation systems and groups to try to find out how do we increase the collaboration across the Fram Strait. If you know, people who work in the marine, that you have the section run by Norwegian and German researchers, it goes across the Fram Strait all the way into the shelf, but the inner part, close to Greenland, is not connected. We'll try to put something extra into this. So it's like a 1 foot and an invitation to get this going, not only the Nordic countries, but also with everyone else, and then expand. On the Canadian side, we have put in a large proposal to the Canada Foundation for Innovation for also a long-term program in the northern part of Baffin Bay. It originally started with something called the Baffin Bay Observing System, and that didn't fly because it was like a big thing. So now we will try to start Baffin Bay North instead, and then concentrate on the Melville section and then across to Grisfjord in Canada. Hopefully that will work, and hopefully we can also start to bridge synergy across with Canada and US. So back to the Isaaffik homepage. So it was actually established to try to figure out who is doing what, where and when. And it was actually a surprise in the beginning that it was not that I did not know what the people in Poland did, but it was actually what they did just in the city next to me in Denmark. I had no clue. Because we were all working in different projects, and usually you're not allowed to have more than one institution. That was how it was in the old days, one institution from each country when you do proposals, so we didn't know each other. So we started in 2014 a meeting called Hinsgavl, because this is a place in Denmark, where we invited everyone from the Danish institutions in Greenland and Faroe Island and discuss how do we get an overview? How do we coordinate? How do we get our work more visible and to increase our collaboration. So we agreed we needed a portal somehow, and we set out. We got half a year to fix it, to make that portal, and that became the Isaaffik. So a little bit of what is Isaaffik and what can it provide. So basically, this goes for infrastructure, logistics, education, research projects, and data. And so in principle, it's a platform like we've seen here also that you can extract data out to other platforms also, but it gives you a list of who is working here, who are the people, where are they? So you can either have a map to figure out where is these projects going. You can do that both forward in time and back in time. You can also put a timeline so you can figure out, is that project occurring near to me or at the same time as me? If so, maybe I could contact the person and find out if we can share a helicopter. You can also go into details. You can get a member, and then you can do. We even have personal homepages where you can sign up. It doesn't cost anything. It's free for everyone, and it's paid by the institutions behind. So it's a bottom-up idea. So just an example of what we have done and how that developed is that we got a collaboration with the Arctic Command, which is a part of the Danish military. And the idea was that the military and the Coast Guard are going around in this area, remote area, regularly. Sometimes they go back without an empty ship, so if they could pick up some of our equipment, we could maybe benefit from saving some money to get it back and forth. And it has been developed slowly just to figure out how do we actually enter this. So it ended up that the defense hired a person and a small office to be a central science coordinator. And now there are procedures where in the Isaaffik homepage you can apply for support. And in 2007, we got 9 applications. One was rejected, and over the years, this has been actually around 40, 50 projects that has been granted, and it's everything from airlift, from actually getting the entire ship and do your own sampling, and most of them has been granted. What has come out of this is also that the search and rescue issue is good. So because Greenland is very big, it's very remote, and police and the defense have the responsibility to help people if they get in trouble. So in the Isaaffik homepage, you can also specify, do you have a doctor on board? What is your set? Do you have experience with helicopters? Can you fly? So all that is gathered and then if something happens, we can coordinate this. It also led to collaboration we do now on search and rescue linked to the real-time observatories, because we can send the data in, use them for science, but we can also use them for weather forecast, and now we also start to use them for if you get people a mayday, the ship is sunk, it was here, and then you'll have an operational model running and particle track that. Today, we have around 700 registered users. We have more than 3,800 projects and fieldworks. Nearly 600 is coming, so you can have a look. Also, everyone in the audience here, if you do anything in and around Greenland, you can see if anyone, maybe you can find some collaborators, maybe you can share costs of logistics. There are 660 infrastructure descriptions and data links around 50. We are increasing on the data links, but I'm very happy that I was attending this meeting because now I know who to talk to, and I think that's more or less it for me.
Thank you, Søren. I was so much hurrying to open the session on time that I forgot to introduce myself. So my name is Kirsi Latola, and I'm based at the Tule Institute at the University of Oulu in Finland. And I have been working, for example, in Interact since the beginning in the EU PONANT and EU PONANT 2. And I work as a research coordinator in the institute where we focus a lot on Arctic research and coordination. So just a little bit about myself, in case you're wondering who the hell is she. So now, the next speaker, Elmer Topp-Jørgensen, a good friend from Interact as well. And Elmer is coordinating the Interact Station Managers Forum together with Morten Rasch, who will be in our panel later. Elmer has led secretariats for the Forum of Arctic Research Operators and Greenlandic Ecosystem Monitoring Program. He has worked for the government of Greenland within the fields of wildlife management and biodiversity and nature conservation. Elmer, floor is yours.
Thank you, Kirsi, and hello, everyone. My name is Elmer Topp-Jørgensen, and together with Morten Rasch, as Kirsi just said, who you will meet shortly in the panel, I coordinate the Interact Station Managers Forum. And the title of the talk today is Arctic and Northern Alpine Research Stations as long-term platforms for addressing local, regional, and global societal challenges. And I have heard there are science activities in the Arctic that are not based out of research stations, but this presentation is going to take it outset in research stations perspectives. So, societal challenges, I guess we all know the United Nations Sustainable Development Goals that all have a lot of sub-goals. And these societal challenges are also relevant at both regional, national, and local scales. And what decision makers need in order to address these societal challenges are robust knowledge. And how do they get that? Yeah, that's through excellent science and local knowledge. And how do you make excellent science? Well, you need state-of-the-art infrastructures and logistical services. And for that, we need to build capacity among research infrastructure operators. And that is why we have the Interact Station Managers Forum. So here a little bit about the Station Managers Forum in Interact. This is where we bring the managers of all the research stations together and share information among research station managers and develop best practices. We also try to improve services offered to the scientific community. And we, of course, cooperate with other infrastructure communities, and this meeting here and workshop is a good example of that. But first, to our stations here. This is just over half of our stations, and they vary very much from small to large, some hosting a few visitors at a time, others more than 100. Some are located in local communities, others are located hundreds of kilometers away, so very off-grid stations. But they all face a lot of similar challenges. So being a station manager, you really need to be a jack of all trades. There's a lot of different things you need to be an expert on, and there's no place you can go to get an education on this. So that calls for sharing of information and identification of best practices. And that is what we have done over the past 10 plus years in Interact. So building capacity among station managers and infrastructure operators, we have, with the station managers, produced a number of books that can help work towards standardized approaches to infrastructure management. And we have all these publications, they touch on management planning issues, risk and safety issues, how to reduce environmental impact, how to reduce impact or reduce CO2 emissions from Arctic science, and also international cooperation. And all these books are available on our website. There are also some books on display outside here, so please take them if there are some left. I don't want to carry them back. So we work a lot to develop good practice at the research stations, but we also try to improve the services for the scientific communities. And one of the things we do there is try to improve the preparedness among scientists, and here we have a very fruitful collaboration with APEX, the Association of Polar Early Career Scientists. So the publications you see up here are all but one made together with APEX. And this is related to fieldwork planning handbook and practical field guides, so very practical books on how to prepare and be best possibly prepared for going to the Arctic. And we have some thematic guidebooks on how to reduce environmental impacts, how to reduce CO2 emission from Arctic science, and something on communication navigation systems. In Interact, we also developed the Interact GIS, which is an online tool to field where you can search for research stations that suit your specific scientific needs. We have seen some example of repositories, and this is a repository where stations managers themselves can enter the information so they can always update the information. And then it's accessible, and you can filter for any research station through all these different variables that we have in the system. And then, as has been mentioned earlier, it feeds into the Polardex catalog. In Interact, we've also made an overview of science-related permits that you may need in all Arctic countries. So you can go to this website, our website, and just click on a country and see all the permits that might be of relevance to you in a specific country. And this we have done much in support of the Arctic Science Cooperation Agreement under the Arctic Council. We're also pushing to improve data accessibility. So the Interact East portal I just told you about, it contains up-to-date information about the research stations in the Arctic. It includes name and location, facilities and services, climate and environmental parameters, and research and monitoring activities at the stations. And it also provides links to how to apply for access to the stations. Then we also have the Interact Data Portal, as Hanela have talked about earlier on, where we provide access to real data from a range of Interact stations. So we do what we can to develop the best possible platform for science in Interact, but we also try to push a bit the science at the station. So we try to facilitate standardization of measurements by linking research stations with existing scientific networks that already have standardized measurements and methodologies. We recommend a minimum monitoring system for research stations. We facilitate free and open access to data. And we also encourage research stations to participate and contribute to Arctic global assessment organizations to address some of these societal challenges that we're talking about. And here we are specifically working together with AMAP-CAF, some working groups under the Arctic Council. So, providing robust knowledge for decision makers. You look at this central map here, is the IPCC temperature projection for year 2100. And you see there are variability in whether how much the temperature will change towards the 21st century. So how well does Interact stations reflect expected changes across the entire Arctic? When looking at the right map here, you see the location of Interact stations. But do we have gaps? Or do we have places where we have sufficient data already? And we tried to look into that, and I admit it is a bit simplified, but nevertheless it gives a good indication in some respects. So what we have done here is we tried to compare the grid cells with Interact stations and compared those to all grid cells in the Arctic using the IPCC climate models. So here you just quickly see two variables, air temperatures and precipitation, and 12 selected stations. This is just to show you that there is variability over time. This is a general trend, but also variability between stations and how much it will change. And here also for soil moisture and biomass, you can also see a general trend, but also variability between stations. So now to the figure that I've been waiting for, to try to explain this in a few simple words. So here you see four different variables: air temperature, precipitation, snow accumulation, soil moisture. And the top row, you see mean values for 2015 to 2020. And the bottom row, you see mean values for 2095 towards the 21st century. No, 2100, sorry. And here we have made distribution curves for the values with grid cells that it contains Interact stations and compared those to distribution curves of all grid cells in the Arctic. So you see two different curves in the middle for each map. And the better the fit between the curves, the better Interact represents change across the entire Arctic. And we made a simple statistical text of mean values, and it shows that there's actually quite a good correspondence in air temperature, snow accumulation, and soil moisture, whereas for precipitation, there's a significant difference. That means that Interact does not reflect precipitation on an Arctic scale. But you can use this graph to see, okay, where is it that Interact network is missing some station, what gaps do we need to fill to make the curves fit? We also looked at 4 biotic variables, biomass, leaf area index, net primary production, and respiration. And there's also a good fit between curves, except for the leaf area index when we come towards the 21st century, 2100. So with this simple analysis, it seems that Interact has a quite good coverage in addressing many of these variables, but of course it all depends on what variable you're looking for. So there might be need for some extra data points, in some cases at least. So Interact Station provides a circumArctic platform to study climate and ecosystem processes and dynamics of societal relevance. So it's just time to get governments and scientists and infrastructure organizations to work together to address these societal challenges. And you should do that by promoting international cooperation and standardization of measurements, which you've already heard a few times today. It's also very important to discuss and promote long-term funding for infrastructure operations, science program, and data management. And it should also be easy for research stations to contribute to assessment and modeling efforts, because I think many people really want to contribute, but it's just challenging knowing what should you actually do to contribute to these things. Because it's all about making knowledge available for decision making to address the societal challenges. So, in conclusion, research stations are individually operated research hotspots that host tens, if not hundreds, of scientists a year, studying past, present, and future changes in the vast and huge, vast Arctic area with very limited human population. And by coordinating and improving and harmonizing procedures for station operations, for science and data management, we believe that it's possible to add substantial value and visibility to this excellent work that's already being carried out at research stations to address research aims and societal challenges. And that is the mission of Interact Station Managers Forum. Thank you.
Many thanks, Elmer. We have already heard today that it's also very important to collaborate and coordinate and work with the other regions as well. And for that, we have our next speaker, who is Hiroshi Miyaoka. And he's from Arctic Environmental Research Center. He's a director of National Institute of Polar Research in Japan. And his research background is in space and upper atmospheric physics, using balloon, rocket, satellite, and ASCAT. He's representative in ASCAT Scientific Association, in NUSMAC, in SIOS, and he's a sub-project director of the project called ARC-CS2. Most welcome.
Okay, thank you, Kirsi, for your kind of introduction. And hello, everyone. And I'm Hiroshi Miyaoka from National Institute of Polar Research. And my research background is, she mentioned, space and upper atmospheric physics. Originally, oral-related physics using the balloon, rocket, satellite, and currently European incoherent scatter radar called ASCAT. Located on Svalbard and mainland northern of Scandinavia. And for these 20 years, I have been committed in the ASCAT and ASCAT 3D project. ASCAT 3D is a next generation phase-array cutting-edge atmospheric radar and one of the S3 landmark program, so supported by EU, being now under construction due to starting the operation from next year. So today I'm going to present on Japan's National Arctic Program, focusing much on the infrastructures and the international exchange program, especially point of view of the non-Arctic and non-EU countries. And okay, so this one. Yes. NIPR has started the geomagnetic conjugate observation for auroral physics between Antarctic Showa Station and Iceland at opposite side. Its conjugate point since early 1980s, but the real systematic Arctic environment program has been kicked off just after the foundation of the International Arctic Science Committee, IASC, in 1990. In this year, NIPR has established the Arctic Environmental Research Center and established a station in Nielsen next year. And the JAMSTEC has also started their first Arctic cruise in 1998 using the research vessel Mirai. And since 2011, Japanese government has been promoting the national flagship Arctic program almost every 5 years. Green Arctic and ARCS and ARCS2, its current program. And during these 10 years, Japan has been affiliated as an observer status for Arctic Council in 2013, then published the first national Arctic policy in 2015, and hosted the, as you know, third Arctic Science Ministerial meeting in 2021 last year, jointly collaborating with Iceland. The main challenges of Japan's Arctic project are so right-hand side, but I will skip that in detail. So this slide shows the whole structure of the current ARCS2 project, represented by NIPR, JAMSTEC, and Hokkaido University. We have totally 11 research programs under 4 strategic goals, and another to prioritize subject on capacity building and strategic dissemination for the variety of the stakeholders in society. To support all these research activities, we allocated the 4 major research infrastructures indicated at the bottom line. Okay. Let's see. And yes, in this ARCS2 project, observation and research site in the Pan-Arctic region are allocated as an international collaboration site under the MOU with key Arctic institutions to promote the monitoring measurement in the area and to utilize them as on-site platforms for capacity building for early career researchers. And this is a very busy, sorry, slide. And to proceed the research programs and yeah. In the ARCS2 program, observational research site in the Pan-Arctic region are allocated as an international collaboration site. And okay, so I'll skip. And yes, the one of the research infrastructure is the research vessel, and I would like to highlight in more detail on our new icebreaker for the Arctic research, which I suppose you would have much interest as a possible future international infrastructure for Arctic research. And yes, this is a current vessel, research vessel Mirai of JAMSTEC, and right-hand side is a training ship, Oshiromaru of Hokkaido University. So we are running, operating these 2 ships for the ARCS project. And yes, this is the another research infrastructures, Earth observation satellite data from JAXA. And these are original Earth observation satellite data obtained by the Japanese Space Agency, JAXA, with their Earth observing satellite GCOM-W, GCOM-C, and AROS, and GOSAT. and providing JAXA as observation satellite data and images to the AXT project community by customizing it to convenient format and or information and the customized as observation satellite data and the images are distributed through the Arctic Data Archive System, ADS. Yeah, next slide. So I will also skip this busy slide. And yes, I would like to highlight in more detail on our new icebreaker for Arctic research, which I suppose you would have much interest as a possible future international infrastructure for Arctic research. And Japan has been conducting the multidisciplinary observation in the Pacific sector of the Arctic Ocean using research-based Mirai, as I shown before, since 1998. She is an excellent performance research vessel and has been collecting the high-quality data. Based on the observation, we published many results in hydrography, biogeochemistry, and marine ecosystem and meteorology, and so on. These results are mainly focused on the sea ice reduction area. However, since she is not an icebreaker, the working area was restricted by sea ice. For further development, scientists had hoped for the icebreaker that could make an observation in the sea ice area. So after many discussions among not only by scientific community, but also decision makers, the Japanese government finally decided to construct a new icebreaker for Arctic science in December 2020. It is decided that JAMSTEC is responsible for the construction and operation of this icebreaker as well as Mirai. The stick cutting ceremony was held in March this year, and now the icebreaker is under construction. So we hope that the first observation cruise will be conducted in Japanese fiscal year 2026. So 4 years now. So the most important concept of the new research icebreaker is that it should be an international platform for Arctic science. So Japan will continue research cooperation with the Arctic and non-Arctic countries and will be leading and taking a role in the pan-Arctic ocean observation using Japan's new icebreaker. Okay. For more detail, please visit the JAMSTEC YouTube channel. There's a introductory movie about the new icebreaker. And another topic in my talk is capacity building and research promotion, but the time is limited. I will focus on the bottom menu. So support for the APEX Asia Pacific activity. And yes, for next slide, yes. In accordance with the objective of the AXT project, especially for priority project capacity building and research promotion, and in collaboration with the Association of Polar Early Career Scientists, APEX, early career scientists from not only Japan, but also other countries are invited to apply for research and observation proposal using the research-based Mirai next year. And Arctic cruise to be conducted from August to October 2023. So this call already opened in early September, and the deadline for submission was on October 20th. Now it is in the review process, and the result will be informed to the applicant by early November. So we will have the first cruise planning meeting in mid-November. So this new initiative is toward the international research platform of Japan's new icebreaker, and we believe that it encouraged the capacity building of Arctic scientists and international research collaboration for Arctic sciences. Okay, so my last slide is an on the 7th International Symposium on Arctic Research, ISA 7, to be held on 6 to 10 March 2023 at the NIPL campus in Tokyo. So we have decided already this meeting will be hybrid format, but since most of the entry restriction to Japan has been relaxed this month, we are looking forward to welcome you at NIPL much more on-site. I brought some printout handout here for you, and we put on the reception desk. So the deadline for the abstract submission is 31st October, but I heard it might be extended a bit later. So it's very fortunate. And this time it's very fortunate for you, but not for us, that Japanese yen has been drastically depreciated recently. So it might be the best time for you to visit Japan for ISA 7. So that's it. Thank you very much.
You can already take a seat in the panel because we are following. So thank you, Hiroshi, and I'm happy to hear about possibly extension of the abstract because I have promised to submit one, but I haven't had time to do that yet. So good for that. So now it's up to the panel, and may I ask all the panelists to come in front to the podium. And the aim of our panel is really to discuss on how the research infrastructures can respond to the societal challenges. And we are not looking at the global societal challenges, but also the local societal challenges, because Arctic is also more than just ice and ocean. As we know, it's also a homeland for a lot of people. And in addition to that, we are also discussing and hearing about how the working together with the industry and also educating the future generations can play a role in all this palette. And I would start by introducing the panelists, and I will go in the order that I have in my papers. So first panelist is Niklas Labba, who's representing an indigenous community. He's Sami people, and he's also leading a work package in Interact on increasing benefits and reducing impacts on Arctic tourism. Then we have Morten Rasch from University of Copenhagen, and he's a scientific leader of Arctic Station in Greenland and chair of International Station Managers Forum, so he's working very closely with Elmer. Then we have Søren Rysgaard, who is still from Aarhus University. I don't think I need to go further on that anymore. Then we have Agata Goździk from Institute of Geophysics in Polish Academy of Sciences. She's coordinator of many European and national educational initiatives, and she's using Arctic and polar research as a vehicle to raise students' interest in science. We have Dupont from PONANT as a science officer of the Commandant Charcot. Eric is in charge of maintaining oceanographic on-board equipment, collecting data, and organizing the experiments managed by the hosted scientist. And then we have Hiroshi Miyaoka, who we just heard of. And same as in the previous sessions, I also have a set of questions that have already kindly prepared for me, so I think that we can talk. And I wanted to talk with the local level and the people and community level, and that's why my first question is to Niklas. We all know that Arctic is changing, and there's a lot of changes that are also faced by you, I'm sure about that. And that's why I wanted to kind of ask you as an indigenous representative that how you have been experiencing climate change, and how has your work changed, and have you been able to adapt on that?
Thank you, Kirsi. That's a very highly interesting question, but first I would like to say that today up in Tromsø, where I'm based, there's the International Sami Day. So actually it's they when you say puures. You don't say hello, but you say puures on Sami language. So my name is Niklas Labba. Just mä olen saamikilli, mä olen lappalainen maa vaahkarparni. So I introduced myself as my family name is Labba, and I'm the youngest son. So we are here to talk about climate change, but I don't know how much the audience here, I know there's very good researchers, but how much do you know about the Sami people? That the Sami are actually the only indigenous group that has been accepted or recognized as an indigenous group in European Union. And in one way, I can hear the first speaker today really lifted up the traditional and local knowledge, how important it is for future research. And I think that the project or Interact, what I'm belonging to, with Margareta and Terry, they have really lifted up the international, or the traditional and local knowledge, Sami knowledge, to international arenas. So I thank you that I'm here today. To the question, if I will go back to, let's say, 1989, I was a young reindeer herder, really thinking that this would be a future for me, just like my brothers and my family were living with reindeers. But then we started to see that the good winters, the winters that, or the autumns actually, where the soil is frozen and then we get snow on the frozen soil. That means that it's the base for a very good grazing. So reindeer grazing is actually not the soil itself, but it's the access to the soil. So if you look what has happening now, or what has started to happen already in 1989, is that the autumns are not as they used to be. They are not freezing. Like today, last weekend I came down from the mountains. Still, in the end of November, the lakes hasn't frozen yet. So it means that when the lakes are not frozen, the mires are not frozen. And the snow is starting to come now, and we are already now knowing that this winter will be probably like the last winter, that the soil will be frozen because it will be warm snow, or snow will fall on warm soil, and then it freezes down on it. So the effect of that will be that more and more reindeer herders in Scandinavia, they are starting to artificially feed reindeers. And by seeing the autumn like this, you have to train the reindeer already now to eat the pellets or the grass. So it's very expensive. So a business that already has small marginals will get even more economically. There will be very high pressure on it. There are governmental subsidies that are for special weather occasions. But we see in Finland, for example, the government says that climate change is no longer a special weather event because they cannot give you subsidies because due to this rain on snow event that freezes the soil. So in Finland, the government is asking reindeer herders to start to adapt to the change, to do something, to start to mitigate the effects by perhaps collaborating with researchers. And I think that the collaboration with researchers, local research station, is one way to perhaps find new ways to meet for indigenous communities also to meet this climate change. There have always been an adaptation. So if we are going back again and looking at the dynamics in the reindeer herding, if we see that as a young reindeer herder, you don't have so many reindeers and you want to have more reindeers, that's like the goal. You have to have a big herd to be a good reindeer herder. So what you do is then that, by tradition, we have always known that there will be winters that will be very bad grazing and reindeers will die. But the dynamic was that young reindeer herders with less reindeers could then actually use this bad winter as a year to be the bigger one. Because it's like a card game, you get a new chance. So if you are clever, if you are good, if you know your land, you can actually get the position. You can really build up your reindeer herd. But now the bad winters are coming after and after. So there is no chance because the number of reindeers is kept up in the same level, but you cannot do any slaughtering from it. You cannot take the profit from the herd anymore because now it's just reproducing itself. So that was the business part. Mm-hmm. But if you look at the society, then we see that young reindeer herders, they start to take higher education, and I would really want researchers to visit Sami communities and telling that this is one way to have a future, or in one way to make not a career, but in one way to help the community by getting to know researchers. Abisko Research Station, for example, they have started to build up a good connection with local reindeer herders. So Terry Callaghan was actually one of those that contacted us in our village to get some kind of cooperation, to ask that what do the Sami communities want from the research societies. So what I'm missing would be that there would be some kind of meeting point between the locals and the research stations. And perhaps this research infrastructure that we are talking about, that would be exactly to create these meeting points. So perhaps that's a challenge for researchers to do the first step and ask the local communities, what can we do for you, instead of the opposite?
Thank you, Niklas. That was exactly what I was also going to ask you, how you do want to collaborate with the research stations, but you already pointed that out very well. So then I think we can go with the Morten Rasch as a next, because Morten is also station manager in Greenland. And like Elmer was saying, there's a lot of work which has been done within the Interact stations on how to build the station capacity and how to work better with the society. But do you see that there's still a need for further development in international infrastructure cooperation, and what are the main challenges that lie ahead if you are building the capacity to address these societal challenges, particularly locally, if you think about as a station manager?
Yeah, to answer that question, one way of doing it is to ask yourself, what was the situation before Interact? And I'm old enough to have experienced a time as a station manager before Interact, and I'm also old enough to have been involved in all the phases of Interact. And if I look back in time until from before Interact, then the situation in the Arctic was that we were the same 90 research stations in the Arctic, but we had no cooperation at all. And we were considering ourselves more or less like, you could say, hotels. The only difference was that we had replaced swimming pools with laboratories, but otherwise it was very much the same. And then Interact came in, and we started cooperating. And actually, during this cooperation, it was not the primary purpose of it, but the primary purpose was very much we need to provide some access, we need to improve our practices in relation to station management and stuff like that. But then during this process, we actually realized that out of this process came a 91st research infrastructure, you could say, the network of research stations. We became an observatory with a pan-Arctic coverage. That's pretty unique. And it also means that we actually have the ability to, whatever we need to monitor or to measure in the Arctic, with this network, with these people cooperating, with these procedures that we have made, with this organization we have built up, with this friendship and all these things that actually takes a lot of time, we are in a position where we can implement these things very fast. So that means that we actually have the possibility of, you could say, adapting to whatever societal challenges there is. Then I will take another perspective. I've also have the pleasure of living in a very small town in Greenland, up in Discobugt. The town is called Goździk, on and off since the 1990s. And when I moved there the first time in 1990, we were a population of 1,200 people in town, and then we were 5,000 dogs. And today I'm going back on Monday, and then I'm going back to a town with 800 people. So there has been a small fall in the population, and then we only have 300 dogs in town. So there has been a fall in the number of dogs from 5,000 to 300. And that is mainly due to, in the old days, people in town, they were living from, during the winter, they were living from taking their dog sledge, going out on the sea ice during the winter, and then they were catching fish during the winter, taking them into town. And then in the winter 1995 to 1996, there was suddenly no sea ice in the entire Discobook, the entire area around this town. And it meant that they couldn't use their dogs to go out. And then there was a change from, you could say, subsidizing yourself from an economy based of dog sledging and to do things by boating instead. And if you live in a society like that, there's a lot of side effects in relation to this. It's a complete change of the society. It's a complete change of a way of living and stuff like that. Fortunately, many of them became richer by this change. It's also that if you had looked into the models, you would not have been able to predict specifically this change. The only reason that I can sit and describe this to you today is because I have been present there. So the observing capability of research infrastructure is simply being in place in some of these places. There are many places in Greenland where you can't describe this situation simply because there's been no people, or you could ask the local people. But that is also difficult because, if you come in as an anthropologist, you need a lot of time to kind of figure out what is cooking in this area. So I would say that the combination of the unpredictability in relation to the changes that we will experience, and then the big changes that we are expecting, makes it extremely important to have an observatory that is geared for doing many different things. If I should then go to some more specific things about what is important right now in relation to what could be the role of Interact, what would be miss if we didn't have a project like Interact in the future, then I think harmonized data on the effects of climate change, monitoring, simply doing the same kind of measurements with the same kind of instrumentation, storing it in the same databases, that will be important. Then I think local mining of local experience, like the experience that Niklas has, it's extremely important. I know that these people who have experienced the change in my community, they have gained a lot of knowledge, and they know also a lot about you could say the physical nature that we don't, or the living ecosystems that we don't know as scientists, because we measure things in a different way, and we are not out there during the winter and stuff like that. So mining on these things, and then I would say that securing, and I don't know exactly how it should be done, but securing a better cooperation, or you could say a better synergy between what we call the marine community and the terrestrial community and the local communities, that we establish research projects together and work with a concept where we look at knowledge in a different way than we do currently. That would be an interesting thing, and I also think that that is actually a thing that we could do very good by using the research infrastructures as a kind of the stepstone for getting on with it. Yeah.
Yeah. I have a short question to you. Do you have the local people coming to your station asking for specific projects to be carried out, or do you collaborate in that sense with the...
Yeah, we cooperate in many different ways. The important thing is that if you come as a journalist to such a small hunting community and have your agenda in relation to what do I want them to answer, then it becomes complicated. If you come as a very wise scientist, then it also becomes complicated. If you come and say, I think you have something that you can learn me, then it's fantastic to see what can happen in the, you could say, eye-level communication with the knowledge that we have separately. So that's one way we cooperate a lot with the local community. And then, of course, in relation to, we have in Interact, we have established a plastic monitoring program, and we establish it on 10 research stations in the Arctic. We will use the highest level of the ground school students to do the monitoring. And that means that, I think it's called 10th grade or something like that, that we use in these communities, we use these 10 grades twice every year. They need to go out and collect plastics on beaches, and then they will develop a time series, and this time series will go, we have an agreement with AMAP that it actually goes into the AMAP databases, so they will be used, and then still the kids can also participate in this. And of course, there's also some learning about pollution and stuff like that in relation to this. And then kind of breaking the bridge of being afraid of these very wise scientists is also a good way of, it's also a good way of doing it, yeah. And we have many things like that, so yeah.
Thanks, Morten. So we stay in Greenland, and we have Søren. I have questions for you because you presented Isaaffik as a great database, a website, and tool for kind of finding the logistics and projects and whatever is going on. And how do you see that could be expanded to more broadly within Europe or even in the circum-Arctic level? Is there a potential for expanding that even more? You mentioned the meeting you had a few weeks ago as a kind of a maybe.
Yeah, maybe I'll just start another place just shortly, just a comment for Morten, because I actually forgot that in the presentation. So during our work, we have also got a collaboration going with Greenland on, it's called the Arctic Hub. So we work very closely with the Arctic Hub, with their prime mandate and interest is to kind of synthesize all the knowledge from natural researchers to present them to the local. So there is a very good connection. But Isaaffik was a bottom-up project with different institutions, and it's still a bottom-up, so it's not closed, it's open for everyone. And I am very happy that it's spread out, so NSF has joined a lot of individual scientists, the RV, University of Manitoba, and everyone can join in. And then we build it as it goes, so it's not... I think that if we institutionalize it too much, it loses this kind of, oh, let's do this. Because then everything gets very complicated and have to get, so we like to keep it simple. But it's not a club, it's very open for collaboration. How do you see the long-term funding for that? Right now it is user-funded, so each institution puts something in. And this, I'll tell a little short story now on Rysgaard, if you record this also, but in the beginning the Danish government didn't want to come in. So we decided, okay, let's do on the institution a national platform without the official Denmark. And then it took only 1 or 2 weeks before they came. So I think also we have a power from below, from the institutes, to actually, this is what we want to do. It doesn't have to fit into a political thing, it makes good sense. And sometimes you drive this also by scientists. And I'm a little afraid that it is... that it sometimes can be seen as you have people sitting far away in a big office and deciding what people should do. I would like very much that the young scientists who come in and get a crazy idea, it shouldn't be too complicated to figure out. They should just do it. So the simpler you can get it, the more operational it will be. It also has an educational component. The Isaaffik, what is that? Is that the kind of a research training, education, or? Yeah, so what we did was that we realized, I also lived in Nuuk for 7 years, and I have a lot of kids, and they go in school, and I realized that my wife was very concerned about all these kids going away from school, and then I realized, oops, this is a situation for a lot of Greenlanders. Their children goes away, and they have to take an education, and many times they don't come back because they find a girl or a boyfriend. So we came up with the idea, what if we made we made a candidate courses in Nuuk. So we fly all the teachers up. We got the money to build the building. Today we have courses year round. And now, if you are being a Greenlandic student who go in, who take a course in, or has their primary education in Norway, England, or Denmark, they can come back and take a half-a-year course, so they can maintain their connection to the homeland. And I think that has been a very nice, but also difficult to get going, because if you do that at different universities, it doesn't fit into the box. Yeah. So, the student has to be in one university. And I said, but can we have two universities? I said, no, because then the overhead goes. So we just decided we're going to have the university people and the ministry people in the same room. And then, of course, they just change the rules. And then it could be done. So then we can start to collaborate between institutions. But there are a lot of thinking in boxes. And I think it would be nice with not so many boxes.
I know. I'm also working with University of Arctic, and that is the thing that we are struggling the most. But it actually gave a nice bridge to Agata, who is doing a lot of education, because Agata has been linking the research infrastructures and research into the education. And my question is that how you have managed to do that, and what you have done actually.
Yeah, so in fact, my perspective is totally different, because I'm based in Poland, so non-Arctic country, even though we have a tradition of polar research and we have stations in the Arctic. But what we found out some years ago is that for Polish kids, because we started with national initiatives, it was extremely interesting to learn about the Arctic and learn about our station in Spitsbergen. And we started using the Arctic research and the polar regions as a vehicle to raise interest of students in STEM, in scientific careers. And this was the first step. We started from Polish initiative. Then, in fact, it was born during one of the Interact meetings that we decided to go up to the European level, and then we ran initiative starting in 2016 for 3 years. The Arctic program, we offered online lessons, but it was before the pandemic. So it was quite a challenge, but also a lot of success. We gathered a network of more than 1,000 teachers and educators from 60 countries. So the interest was much bigger than we expected. We thought, okay, as partners of 6 partners in consortium, 5 countries. So if we have 10 countries on board, that will be quite a good number. And we ended up with 60 countries and many continents as well. We continued with this offer, and even now we are hosted by Interact to offer online webinars for schools. Our network is now bigger because it's almost 2,500 teachers and educators all over the world. And if any one of you is interested to spread the word about the research you do, about the stations in the Arctic, please contact me, because we are organizing that from the technical point of view, from the promotion, enrollment of schools, and you could easily share what you do with the schools. One point was, of course, to teach children about what's happening in the Arctic. And from the surveys we conducted with teachers, we know that we were effective because we had like between 90 and 95% of teachers participating in the program said that definitely the level of knowledge about nature, natural resources, but also some societal and political specificities of the Arctic raised. But from my perspective, what was crucial, it was raising the awareness of environmental problems and the challenges and the climate change. And the Arctic is the perfect topic, and if we talk about environmental challenges. So this is something to convince students that it's not about a polar bear starving somewhere on a sea ice block, but it's about people living there, but more importantly also about all of us. I mean, as it's not staying there, the Arctic amplification is about what happens also in the rest of the globe. So this awareness raising is crucial. And also, I see that in order to have it running and to be effective, we need engagement of 3 groups. One, teachers engaged and willing to connect with researchers, enthusiastic in their work. And we met many of them virtually, but they are still a part of the network. The other group, absolutely crucial, are researchers willing to share and understanding that it's important, and also trained, because we need to have scientists speaking in a simple manner, but still correctly, which is not that easy, in fact. And the last but very important group are policymakers, starting from heads of universities or institutes, stations managers, but also on the level of ministry, to understand how it's crucial, how it's important, and also to give this possibility for researchers to act this way, and also to evaluate their work so that they know that it will be something that also counts for them in their scientific career. So this is at the very, very up level, but also crucial to make it running.
60 nations, did you say? 60 countries?
60 countries.
How do you manage the language? Is that something that you...
Yeah, this is mainly English.
Yeah.
As we have many schools in Poland, we are also conducting online lessons in Polish. But what we also developed during the Adriatic project, we had Polarpedia, which was an online encyclopedia dealing with polar phenomena and explaining in simple manner. And we also started with the languages that we had in a consortium. That was the idea, that we will prepare that. But then we found out that teachers are so interested in that they offered to do that on voluntary basis. So we ended up with 16 languages instead of 6. So
wow.
That was, we really saw the interest of the end user. That was great for us.
Well done. Excellent.
Thank you.
Okay, then we take another leap and move into the industry. And Erik, we know that industry operating in the Arctic has also the responsibility to contribute to protection and understanding the environment. And my question is that what actions do you think that industries can take forward in contributing to safe operations in the Arctic?
Thank you. Yes, there is no doubt that there is increasing demand of the market to get to areas that are virgin or protected or not protected, but areas where nobody can easily get to. So since the market demand is high, obviously the industry will offer something for the market. So I would say the industry is more an opportunity or even an asset for science than just an evil. And so how the industry can help science? I would say there is 3 main axes. The first one could be operational. I would take the example that last year we helped 2 icebreakers to get to a strategic point for science. It was a Sir Attenborough icebreaker in Antarctica, and in North Pole it was the Akon icebreaker, because the Commandant Charcot is very, very powerful as a nuclear icebreaker. So I wouldn't say that Commandant Charcot could be stopped by the ice. So I think it's if we could collaborate together and anticipate cruises, I'm pretty sure that we could help scientific research vessel to be with us, and so that we can open seas. Such Russian icebreaker are opening seas for commercial container ship. We could also open seas for science vessel, for example. Second aspect is the data, of course. You have a very, I would say, deep data to get, but I'm pretty sure that the Commandant Charcot could also get data that are reliable, robust. And if we can share the data that we are acquiring through CTD physics data, I would say, or biology data, maybe we can save some energy for other science projects so that you get this data in advance so that I can adjust my next project because I can build the next scientific project using this industry data. So the challenge is on us because we need to make sure the data are calibrated, maintained, robust, and so the intercalibration is correct. And the last point maybe would be, well, something that is maybe more challenging is education. We won't change the world, for sure, but even around us, if you ask a question to your friends, what is the Arctic image they have? Even I am an oceanographer, but I am from the French Navy, so I was not supposed to study the polar region. And now I know the polar region, and it's not empty. I thought it was only polar bear, seals, and ice. That's it. But actually, I think that very few people understand that at the pole, there is a start of a lot of things about the climate change and the climate for the planet. So when I conduct some experiment on biology, studying the phytoplankton, the neutrons and everything, or even nanoparticles, I realize that the pole are so key element to understand the whole planet systems. And I'm pretty sure that when I'm welcoming thousands of people in the lab of Commander Charcot and I explain how and why Arctic studies is so important, significant, then I'm very delighted to share my experience and to convince them that the Arctic and the Antarctic is a key spot to study. And people, I would say, I don't change their mindset or I don't change their attitude after, but I just, it's a seed that I'm getting into their mindset so that when they get back to Paris, Tokyo, New York, whatever, they have this idea of, okay, I saw a polar bear, but behind the polar bear, I know that there is a whole food chain. I know that there is a whole challenges about the pollution into the Arctic and so forth. So I think it's a little bit more challenging for us, but I think it's good that scientists that are hosted by PONANT on the Charcots can help to educate people. Educate is a big word, but I would say sensibilize people about the Arctic challenge.
Thank you. I'm happy to hear that because that's one of the challenges I have always felt. That it's really hard to make the people understand that things are connected and that polar bear is also connected to the people on the coast and so on. So I'm really glad to hear that. Our last panelist, Hiroshi, you mentioned that Japan is now building up a new icebreaker. It was something that came to my mind when I'm listening to Eric. And I was wondering if you could elaborate a little bit at what kind of barriers or opportunities you see on how the Japan can collaborate and communicate and work together with the other regions if you think about the whole global circumarctic field.
Your question is with our new icebreaker.
That was one example that came to my mind, but as a whole, if you think about Japan Arctic research, do you see any barriers on how you could collaborate with the circumarctic other countries or any?
I'm not so solid barrier to cooperate with the Arctic countries and non-Arctic countries worldwide. And you know that we are collaborating with Asian countries with the framework of AHOPS consortium. And AHOPS stands for the Asian Forum for Polar Sciences. So it means AHOPS covers the Arctic and also Antarctic sciences. And I have not so much involved in the AHOP's activity so far. So honestly speaking, I'm not the right person to speak on AHOP's activity on behalf of my institute. But my impression is that AHOPS is very effective for the research collaboration with Asian countries for the Antarctic activities. We invited the scientists to our station, and our staff, NIPR staff, will participate in another station. It's a very nice collaboration, and we every year hold on the international workshop under the AHOPS framework, especially for the medical members, staffs for the Antarctic stations. So it's very effective activity. And I feel that, my feeling is that AHOPS activity for the Arctic region is not so enough now. Yeah, but my expectation is with the introduction of the new icebreaker, we will have the much opportunity to get together for collaboration, especially by the young researchers, by early career researchers. So that is the reason why we introduced, and JAMSEC introduced that APEX early career scientists invite to the Arctic cruise next year. It's just a trial. So my expectation is we are getting much more activity we will see in the Arctic region as well.
That's excellent. Yeah. Thank you. I would now ask the audience if you have any questions to any of our panelists. Renuka.
Thank you. I just wanted to add to Hiroshi-san's comments about AFOPs and cooperation. The European Polar Board recently, last week, held a meeting with the Asian Forum of Polar Sciences to exchange information about infrastructure in both Arctic and Antarctic. And we will be happy to share this information in a short report, which should be out soon. So I think if that's of use to any of you, please have a look at the EPP website in the coming few days. Thank you.
Thanks, Renuka, for that information. Any other comments or questions from the audience? Nicole first, and then.
I have a question to Eric. When we worked in ARISE, we identified, of course, that industry, not only cruise ship industry, but industry in general, is collecting an enormous amount of data. But we had the feeling that some of the industry, at least, does not know what to do with the data.
Absolutely.
Yeah, and my question is now, what can we do to help you, or in general the businesses, from our side, to make sure that your data is ending up, for example, in EMODNet portal or in other portals? So is there something we could do from the scientific side to promote this?
Yeah, you are absolutely right. I'm sure that in the lab of Conan-Charcot, we have tons. It's maybe not tons, but a lot of data that are just in a repository database. And I'm not sure that one day this data will be useful for any lab. And this is Conan-Charcot, but a lot of other commercial ships have a ferry box, for example. And I don't know who is using this type of data, actually. I don't know. Because a ferry box is something like about 60,000 euro or 70,000 euro with calibration, maintenance. And so it's a pity that we cannot use this data. So first, I would say we need to make sure that the data are reliable and robust and well maintained, well calibrated. And I'm not sure that all the sensors are calibrated every year, at least by a certified laboratory. So we may have some scientists should maybe establish, but maybe a ModNet could be able to do it, a kind of a template to make sure that this type of data, for example, I don't know, salinity, for example, has to be done in that way. Because we have the industry guidelines. So when you buy a SBE seabird sensor, for example, they say, okay, you should do that. But what about science lab? Sometimes, for example, IFREMER advises to use this equipment in the different ways in the industry, or the manufacturer is advising us. So maybe we could have a kind of a template or science lab feedback about what is the right way to use the data. And then we have to, broadcast and to educate the different captain and the different crew of ships to make sure that they will send the data to a repository database. And ModNet is kind of a really nice initiative. We could focus on this type of database, I don't know. But definitely there is something to do here. I think it's the weakest point of our job today, I would say.
Okay, thank you. Please.
Okay. Little low tech then, but first clarifying this ferry box data from some of the ferry boxes in Europe, they are going into Copernicus services. So there is a mechanism of absorbing the data real time and putting it into forecast. They are not doing that for the Arctic yet.
Okay.
I want to address, so the Arctic is undersampled, so we have to take the opportunities to get there. We have in Norway at the NASA Center is also using the Coast Guard. I heard the Danish are using also the Navy. And my colleagues also had the pleasure of joining the maiden voyage to the North Pole with Le Commandant. And what we deployed there, and that comes to my point, and that's your third point, we deployed on the North Pole a bunch of wooden boats made by school children, simple, low-tech, and together with a drifting buoy giving the positions as long as it were on the sea ice. Then the boats disappeared into the Fram Strait, into the Icelandic Ocean, and suddenly popped up on the northern tip of Norway, on the west coast of Norway, on northern tip of Iceland. And that kept the engagement of these school children for several years. Yeah. So they suddenly realized that what I made in 2017 or 19, and that were deployed on the North Pole, quite exotic, popped up later on, and they were thinking, okay, how could it use so many years this time? And that's really education. So I think this awareness, the third point of view, is extremely important. In addition, that we need operational support and provision of data, because you are at a place where very few other people are.
Yeah, it's a very good connection between science or citizen science and passengers. And actually, a lot of passengers ask us, what about my boat? Where is it? And so there is no GPS device on each boat. It's a wood, so that's a good. It's not pollution, so that's good.
I have one question I wanted to address to panelists. Any one of you can answer as a kind of a final before we break. Is that if you think about from research infrastructure view or from your own view, is that what is needed to be able to continuously address societal challenges now and in the future? So what needs to be done more? What can you do more? Does anyone want to take? If not, then it's totally okay, because I think, do we have a coffee break now? Yes. So you can go. Yes.
More workshop like that, so that everybody knows everyone. And so it's always good to collaborate, but collaborate around the coffee and the lunch is even better.
Thank you. And thank you for our panelists.